Okay, so this is an emerging bowl. It's called that because it looks like it's emerging from a solid block of wood. Now, if you go on YouTube and type in emerging bowl on YouTube, you'll see maybe half a dozen or more people doing these. And one thing all those guys have in common is they use a bandsaw to make this work. But my method requires no bandsaw. Okay? So what you're going to do is you're going to take a big block of wood like this. This is two pieces glued together with what's called a paper joint, okay? Where you put glue, a thin layer of glue, evenly distributed on both sides, but not too thick, and you put a piece of paper in between. I use brown paper bags, but you can use newspaper, and they both work. You stick them together, you clamp it overnight, and then if you're very good, this one, the glue, the wood slipped a little bit as I clamped it, and I didn't adjust, but close enough, and I just marked the center of the wood. So once you have the block of wood, you turn a tenon on one side, then you turn a hemisphere. You're turning it on the lathe like this, spinning like this, you turn it to hemisphere. Then you split the wood apart, it'll look like this, then you mount it this way and you hollow out the bowl. So those are the steps we're going to do today. Now I do want to mention that this was my very first demonstration to the club, was a emerging bowl in 2016. And I was a turner maybe for 4 years before that. I looked at the video that you can still find on the club's website, the YouTube site, and it took me, I don't know, half hour, 45 minutes just to turn it round on the end. I'm going to be much faster today. I've learned how to make spheres much better since 2016. And then I hollowed it out. I was very slow hollowing it out, being very careful. At the time, in 2016, I only had 4 tools. I had one bowl gouge, one parting tool, I had a carbide easy wood tool, and I had a homemade boring bar, and called an Olin tool. So I did everything with just those 4 tools. Then I expanded to 5 tools. I took an old kitchen knife and made a second parting tool. So anyways, now I have about 100 tools. Yeah. I think that's it. I have one joke, okay? I had a birthday recently, and all I got for a birthday present was a deck of sticky playing cards. And I'm having trouble dealing with it. So, you look at this piece of wood, there's a pith here, there's a branch coming out, a little bit of cracking there. I can, after I'm done with this, I can face this off to get a square, a perfect square edge. So I'm going to make this the chuck or the tenon side. Now here is my safety center. I don't use a spur center anymore. Typical spur centers like this can be used. This is a spur center. I use a safety center. This one is a robust center. It has this extra attachment that it calls it a bowl center this way. This is the typical safety center without that used for spindles. The robust one has this extra piece that you can thread on and make it work. So using this, you only need tailstock pressure. So I've got a small hole in the exact center. You could actually, it doesn't have to be centered along this direction. It only has to be centered right on the glue line. Okay? And I've marked that with an awl. Doesn't look right. All right, that's good. So you're only using tailstock pressure here. Okay. Now before I go any farther, let me show you my tools. Here's my 2 bowl gouges, a 5/8 bar and a 1/2 inch bar. They're ground to the Ellsworth grind, which is a 60-degree bevel, swept back, and the heel is ground off. This is a Thompson tool. This one is a crown tool. I got this at the Jim Pugh estate sale. Still going good 8 years later. I probably won't use the spindle gouges very much, but I do have a similar setup there. I have a 5/8 bar and a 1/2-inch bar for spindle gouge. The bevel is maybe 35 degrees, and again, the heel is removed. These are the Hasseluk grind. So I just matched, I bought the tool from him when he came here to the club, and I just matched the settings on the Wolverine jig to make these grinds here. Parting tool, nothing special. It's a Thompson tool, maybe an 1/8 inch wide. A Bedan to reduce the wood to a cylinder. So this is about 50 degrees, maybe 45, and it's just straight across. It's like it can be used as a parting tool, but it really removes wood fast. Okay, then I got a bunch of scrapers that I brought just in case I need them to smooth out the inside of the bowl. This is a conventional scraper, 75-degree bevel. All right, conventional scraper, another conventional scraper, negative rake scraper, okay? I use conventional scrapers more than the negative rake. I have better luck with them. I can't explain it. Maybe I don't sharpen it quite as good. And I also have a shear scraper, just I use on the interior of the bowl, okay? So this can be rotated. Removed for sharpening, attached, and you can put it at a shearing angle. It's good for smoothing out the inside of a bowl. I've got a skew. I'll use the skew for just a very short portion of the turning here. This is a powered respirator. This is the battery. This is the battery. Filters in here, sucks in air through this, and it blows down on top of your face. There are about 5 or 6 different brands of these respirators. I highly recommend getting one. The average age in here is probably 55. None of your lungs are very clean, so why make it worse? Okay, the first thing I'm going to do, I'm going to make a tenon, okay? I do not want to chip these edges. I want to keep these edges square. So I'm going to use a skew to make the first cut, because if you use any other type of tool, you risk chipping off the edges. Check to make sure. All you're relying on is tailstock pressure here. Okay. Okay. Yeah. Okay, now I'm going to smooth this out, make it perfectly flat. Now you can hear the different noise when I'm cutting out here. It's an interrupted cut. When I get to about here, it becomes a continuous cut, and the noise is much lower. The noise is much reduced. Now you can see the cut is getting cleaner because I'm paying more attention to a fine cut, but I have to remove a little bit more to get down to this this edge. So you're just going very gentle, and you're trying to get a perfect smooth cut inwards. Rubbing the bevel, bringing it out. Yeah, that's good. Now, my first thought was to make this perfectly square all the way down, but I realized this is the end that's going to be removed after I'm done, because you don't want the tenon on there at the end. So I'm just going to leave these steps in here, and I'm going to work on making this the tenon with the proper angle. Now this is a dovetail jaws, so you need a dovetail angle. And this angle here should be 90 degrees, but 89 is much better than 91. So I'm going to make it slightly slanted in, okay? And the way I do that is with a spindle gouge. Okay, this angle is appropriate for the dovetail. I just eyeball that. I don't measure it exactly. Now I work on this. All right, that looks good to me. All right, so this, I'm also looking at the quality of the cut. Even though it's going to be removed, I like to still practice good tool control to get a good smooth cut. You can see that there's very little tear out on these two surfaces, which means this wood is well behaved. I have a smaller one-way chuck and a larger one-way chuck, and this is halfway in between. Okay, that looks good. I'm inspecting down this, making sure there's no gap between the top of the jaws and the flat that I made on the wood, and it looks quite good. I'm going to use tailstock support. It's not quite necessary, but it never hurts, so I make a practice of doing that. Make sure you're not going to hit anything. So now my goal is to make this. Okay, this used to be square, and I removed this much wood to make a round sphere. Skew chisel, I'm going to go to about here just by eyeballing it. Okay, that's a little bit more. All right. Okay, I'm going to use a bedan. I'm going to start with the tool handle very low. I'm going to raise it up until I get cutting. Now, I don't know if you can tell, you see these chip outs like that. That would be a risk you're taking if you don't use the skew to start the cut. But really, this isn't too bad. This wood, this is maple. It's a real nice piece of wood, and it looks like it's not vulnerable to chipping out. Big chunk coming off this way. I want to mention something else too. This is dry wood, therefore it's hard, and it's not. And look at that, yeah. Because it's dry wood, you have to push harder, and your tools get dull quicker. These are made, which I signed at 2015. This was with wet wood. After I got all done, I made the sphere, I rounded it, hollowed it, finished it, and everything, and started to check really bad. And I filled all those cracks with coffee grounds and CA glue, and I waited another year, and they had all opened up again because they still were drying very slowly. So I still think it's worth it to use dry wood because of the cracking potential of wet wood. Because you're drying something that's this thick, it takes a long time. Also, I tend to make these in spindle orientation, so the grain is running this way, but there's no real reason you couldn't do it the other way. You could turn it faceplate orientation. So if I took Ron was suggesting using a bowl gouge. Give it a shot. That's fine. It's working just as good as this. I'm going to save the bowl gouge because I want to keep its edge for later on. Just going to you can use this Badan for a little bit more. Okay, so I'm just now getting it to the biggest cylinder that this will accept. So I'm going to remove the rest of this wood, then I'm going to fine tune the diameter here. Okay, so and you can see that this block of wood that I started with was a rectangle. So on this side, I've got about 1/4 of an inch of margin between the flat and the round. On this side, it's only a 1/16 of an inch. So I have to remove a lot more wood to make it aesthetically pleasing. So I'm going to go down at least a 1/2 inch. Okay, now you see this gap is about almost 3/4. This gap is about a 1/2. Because of this chip out, I'm going to go down just a little bit more. And to do that, again, it's an interrupted cut. You've got to be very careful. Let's see how I do. Okay, the cut is very clean. There's a few ridges in there, a little bit of tear out on this side only. But it's pretty good. I'm going to now spend a few cuts to get it perfectly square. It's a little bit of waviness in there. I like a spindle gouge for that, but you could still use the bowl gouge. Okay, that's pretty good. It's pretty square. It's pretty clean cut. I'm going to spin there's a little bit of a ridge there. I'm going to try to get rid of that. Yeah, a little bit more. All right, I'm going to claim victory there. I could address the rest of those grooves with sanding if I need to. All right, so now I'm going to make this a perfect cylinder. I'm going to do some measurements. Maybe I'll use the spindle gouge. If you do this, you line up the tool rest with the bedways. It'll help you make a straight cut. Okay, that looks good. So this distance here, from the round to the square, ends up being this distance here, or this distance on the side. So you have to make sure all four sides are where you want them. You see on this one here, the gap is larger here and smaller here, as opposed to the one I just showed you. That's all just artistic choices there. Okay, so now let's measure this diameter. Okay, 125. So it's actually 125 and a half. I'm just going to round it up to 126. I need to know 0.2 of that, which would be 252, which is, I just multiplied by 2, 12.6. Yeah, 0.4 is equal to 50.4, and 0.5 is equal to 63. Okay. So for 0.5, again, this is going to be a hemisphere, so this needs to be, and I also got to remove a little bit of this because of the hole, the indent. So let's see how I am. This is 65. That's perfect. All I do is flush this off and I'll have it there, okay? So now I go to the 0.2, it's 25, 25.2. That's the beauty of these digital calipers. You can, they're right there. And you go right there. Turn the speed way down. Okay. Yes, 20% of 126 short is you double it and then you move the decimal point over. Yeah. You could use a calculator. Okay. Now I didn't actually need the 0.4, but if you, the distance from here to here is 0.2, distance from here to here is 0.4. I think that's right. 0.3, yeah. So anyways, this is known as the octagon method. If you need a review of that, Pete Wade covered that a couple months ago, and I covered it in a YouTube video called 5 Ways to Make a Sphere. You're going to cut off straight across from this line to this line in a straight angle. Once you get that, that's the most important cut you need for a sphere. Okay. Now, another safety thing here, this tool rest is fine for this job, but I prefer the bigger one because if I'm not paying attention, I don't want the sharp corner to hit me. So this tool rest will tell me I'm safe out here, okay? I have no idea why that happened. Maybe just taking too big of a cut, I guess. Now, notice I was standing here. If I was standing here and doing that same cut, I would have been right on the line of fire. It would have been much more dangerous to me. So it's better to stand here. I think I was just taking too big of a cut. That's my guess. I'm going to slow it down a little bit, play it safer. Okay. And try to get it in those jaws better. All right, that's a little better. All right. Let me double check everything here. Yeah, looks good. Once burned, twice shy. Use some tailstock support. Okay, you see the quality of the cut? It's pretty good. There's some tear out here. Just gonna have to live with that. But this line is pretty straight. So now, take my pencil, slow it down a little bit. Go halfway in between this edge and this edge. Halfway between that. Halfway between these two, halfway down here. Okay, so now I'm going to switch to a sharper tool. I'm going to remove this corner by going from this line down to that line. I'm going to do the same thing here. I'm going to remove this corner by going from this line to this line. Okay, now I'll take this one off while I'm here. Now before I get into trouble, I'm going to remove this little bit on the end so there's no hole anymore. Okay, now it's reasonably round. The rest is just making it by removing the edges, the sharp corners. Okay, so how do you tell it's round? Or not round, circular? Well, in the video that I made, 5 Ways to Make a Sphere, I started with templates. You could measure this diameter, cut it out on cardboard, hold it on there and see where it matches or not. That's one way. The better you make this as a sphere, the better your merging bowl will come out. You can see some of the ones I made back in 10 years ago wasn't too good of a sphere. And you'll see, I'm going to show you a way to compensate for that at the end. But some of these are very poor spheres. Like this one is probably the worst one. You can see it's very flat there. When I drew this with a compass, you could see it just several places where this is out of round. So again, I'll show you how to compensate for that later. But the goal is to make a perfect sphere. So making a template is one. Using what's called a ring gauge is another. This is a piece of PVC pipe. I put it in the chuck and I put a chamfer on one end. So you go here, hold it here, and you see if you see a gap. So right now I see air here and here, so that means I got to take off a little right here. Okay? You could use this wherever you want and see how far you have to get off. Okay? And then again, I covered these. These are my hole saw scrapers. This is a combination of a gauge and a cutter at the same time. This is made with a it's made with hole saws where the teeth have been ground off. And I'll show you how to sharpen these too, but the burr, I use, the cutting edge is on the inside. So I'm going to hold it here, I'm going to move it around, and it'll scrape the wood. But before I do that, I'm going to fine tune this as best I can before I resort to those. This tool is already a little bit dull, but the wings are still good for scraping, shear scraping. And this is a heavier bar, so I could go farther off the tool rest before it vibrates. Again, holding the tool like this is what's called a standard scrape. Holding it down like this makes it a shear scrape. Still got a little bit of a bump right there. Okay, now. So what I'm doing is I'm watching this top contour while I'm cutting down here. Okay, there's a little bit of a bump here. All right, let's see how that looks. I'm going to move the tool rest out of the way for this. Okay, this is very hard wood. This is very soft steel. So you got to rotate it to get fresh cutting. All right, you see this, it is cutting, but I realize it's very flat on the end. I got to do more work on the gouge before I spend too much time on this. All right, much better. Okay. Now the gouge, making a very clean cut. There's a little bit of tear out here and on the opposite side. When I use the scraper, it's not going to be as clean of a cut. This torn out area will be even larger. But I'm going to, I could work on that a little bit harder, but I think I'm just going to live with that and use some sanding to get rid of it. If I was wanting the cleanest cuts, I would not use this hole saw. I would use this ring gauge and try to get good bevel rubbing cuts to get rid of that. Could worry this a little bit more, but I think I'm going to just live with it. I'm going to claim victory here. If you got close, you could see that it's a little bit of flat spot on the very tip. I have two hole saws. This one's slightly smaller. They're both in the range for use with this size sphere. Okay. You have to push hard enough that it doesn't vibrate. Now this one here, I made one mistake with these. When I put the lag bolt in here to hold this in place, I put epoxy down in the screw. So now this thing is 10 years old and the wood has moved a little bit and this could rotate. But I can't get the lag bolt out because it's epoxied in there. So this little bit of shifting is undesirable. That's pretty good. I'm going to claim victory. Let me just show you how to sharpen this. I put it here, and sometimes I go up to here. It just seems natural when I do it. If you put it here, obviously it'll come around and whack you. Put it here, I'm just too close to this. Okay. Also, I only did this once. I left the tool rest here, doing it, and it caught it and went bam. And someone's finger was in between the wood and the steel. I don't like to do that. All right. So let me show you how to sharpen it. You're going to just hold it freehand on the wheel, and you're going to lightly rotate it like this. And you can feel you'll feel the burr right away. It takes like 10 seconds. Well, I'll show you during the break how to sharpen these if you want, way over there. It's going to be off camera. Okay, we're done with this section. Yes, could do some sanding. But if it's not perfectly round, whatever you do for finishing is going to be have to be redone. All right, I'm going to use the drill press for that. I'm going to show you that in a minute. Next, I'm going to break it apart. So you saw that when it was turning, this glue joint was pretty damn strong. It didn't fail when it fell out of the chuck or anything. Okay, this is just a utility knife. You could use a chisel, I suppose. Put it right on the glue joint. Not too hard, huh? Okay, now if I look at that, it's pretty round, a little bit squashed on the tip. By the way, this one here, you can see I use newspaper on this one. It's pretty much the same. Same easiness of splitting. The only real thing about paper joints is you don't want too thick of a glue when you're gluing it together. Okay, now got a pencil. Okay, now this is a standard center finder, but you can't use it to a tremendous where you'd like to, because it bangs up against the edges there, the shoulders. I use a compass to double check. Yes, that looks pretty good. It's not perfect. The outer sphere is not perfect. Okay, so now I'm going to mount it. This is what I'm going to use. I'm going to mount it on this. These platforms are very useful. This is the first one I made. This one is for my smaller lathe, my jet lathe. It has a 1-inch spindle. This is a 1 1/4, and the larger one. This one here, I also drilled holes in it, and I used it as a donut chuck. Okay, if you're not familiar with a donut chuck, you make these rings with holes in it. You could put a bowl in there, and you use these bolts to screw it down. So you could center it. You could reverse it, do the bottom of the bowl or the bottom of the hollow form or whatever by clamping it in between 3 of these bolts in this with this again, a donut chuck. I used to use this quite a bit. Sometimes I would even use these top rings. I would just hot glue my bowl upside down on here. I could get it centered with the aid of these rings and the edge with a gauge, and I was able to finish off the bottom without much trouble. But I use jam chucks now most of the time. So this one here, for a bigger lathe, my newer lathe, I made it much thicker because I wanted more weight. Okay, you're going to be turning things off axis a little bit here, and the more heavier it is, the better off you're going to be. Okay. Okay, so what you're going to do is this has to be mounted like this, the small. So I'm going to use this hole as an alignment, bring the tailstock up, and temporarily glue it in place. To do that, I'm going to use a combination of hot glue and double sticky tape. This is Turner's tape. This is not carpet tape. It's not Scotch tape. It's Turner's tape. Okay. Okay, get this out of the way. Lock this up. All right, it's aligned as best it can. Now notice it's cantilevered off center. I compensate with this wedge. It's going to go like this. Also got double sticky tape on this one. Okay. Now, you don't want to put this on at an angle. You want to get it straight here. Come up and you press. Okay. All right. Now, to clamp this. Okay, good enough. Okay. Now here, because it's a single point and it's cantilevered off, it's not necessarily providing even pressure off here. So the way I do that, okay, so the Nova Live Center has 5 or 6 different tips that you can put in here. This is the widest one, it's a cone. All right, that is strong, providing good clamping force. Now, I would think you can get away with just this double sticky tape. But again, play it safe, I'm going to use this. Okay, move this out of the way. It looks like it's canted a little bit, but I'll have to live with that. I'm going to put a little bit of glue on the wedge here. Get some down in that where the wedge touches onto the sphere. Okay, go on this side. This side. Okay. All right, I'm going to let that sit for a second. I'm going to talk about design. So, the standard box the way I make them, I make most of these, is like this. Okay, so this distance is healthy. So the rim might be a 1/4 inch rim. This is between 1/4 and 1/2 inch, both sides. And this distance here, I've seen some on the internet where they make them very small. Like this. I don't think those look nice, okay? I prefer something about like this. But there's no reason why you couldn't make it this long, okay? Here's an example of one Rick made where it's kind of long. This distance is equal to this distance. My thinking is you could almost use the golden ratio here. Between this ratio here could be 2/3 and this could be 1/3, something like that. But mine are roughly 50-50, I would say. Yeah, about 50-50. Next thing is, it doesn't actually have to be on center. You could make one on the corner. Okay, that would be kind of nifty, I think. The other thing is, when you look at it from the side, this distance has to be significant. If it's too close, if it's too small, that distance, if you made it like this, it doesn't look like it's overhanging enough. So I think you should have at least a half of an inch, as much as an inch of gap between this surface and the bottom of the sphere. Okay. The other thing many people do is, I drew this wrong. This should be. A lot of people, they will cut about a quarter of an inch off of here and make the bowl stand out a little bit higher up. And that's a personal choice. I don't particularly like it. I like to see it flat, but a lot of people do it that way. You'll see that on the internet. Okay. All right. So, I'm going to make a bowl now. Now you can face off this entire thing to get rid of this sandpaper. And I might do that by sanding. I'll play it by ear. I'm going to make the bowl first and see how it looks. But I'm a little bit concerned that I didn't get this flat as I should have, that the tailstock pressure caused it to cant a little bit nervous about that. So, now, the way you do it now is you have to bring up the speed slowly until you get vibration and then back it down, okay? Okay, so this line is drawn where the beginning of the bowl should be. So I'm going to cut in with the parting tool just to give me a guide. That's not bad. That's probably 500 RPM. I bet you can't do much better than that without adding counterweights. Now, if you'll see here, the groove is relatively deep here, but right here it's not. That's because it didn't glue right when I clamped it on there. So that's going to require me to face off this entire surface. But first I'm going to cut this groove a little bit deeper. So now I'm looking, and I see that I made the wall, I eyeballed in the wall thickness a little bit too thick of a wall. So I'm going to grow from here out a little bit to make it more final shape. Okay, good. Now you see the tool slipped a little bit, but it only cut through the paper. All right, so the next thing I'm going to do, I'm going to face off this entire surface, and then I'm going to hollow it out. Maybe I'll hollow it a little bit first, and then I'll do that. Now when I started, I was in spindle orientation of the wood. I flipped it sideways, so now this is face grain. So face grain, you always cut from the bigger diameter to the smaller diameter. So you see I'm working this way out and out. See this cut, can't see, but there's no tear out in that cut. Okay, so I'm doing something right for a change. I'm holding the tool into my belly and I'm twisting it. Now the other thing with this, as I hollow it out, it'll get more and more out of balance, which is the opposite of usually if you mount something rough wood on there and you're trying to turn it, after you get it round, you can turn up the speed. Here you can't do that because this heavy piece is on the outside. All right. I'm going to switch to this. I'm going to face off this surface here. So you can see this paper has been removed from here, all this, but not on this corner. So this has to be cut in a little bit more. That scraping cut is not the greatest, but it's not bad. I guess I could come in with a slicing cut. That's not bad. And just smooth it out a little bit and live with that. Move on. Oh. Okay, I got a little bit too aggressive. When I got out to this far part, I was pressing too hard. As I came around, I went below center. Okay, I went below the surface. So let me just do a little bit more and then stop. All right, that's pretty good. Now I'm going to hollow out this. See if I can speed it up at all. Not really. Okay, I'm going to start measuring wall thickness. Because it's a little bit canted, I want to make sure I measure it from the same spot every time. Okay, so I've only got about 1/4 of an inch of the right thickness, and I've got to remove quite a bit of wood from here down. Okay, a little bit more. Okay, I'm about halfway down. Okay, right here. Now you could also use a template on the inside. Cardboard, hemisphere, stick it in there of the right diameter. You might have some good luck with that. I'm just doing it by eye. Wow. All right, I'm going to switch to scraper. I have good luck with scrapers, so I've give those a shot. I'm going to come in here. See, I'm right on dead center. I go up above center, and I'm going to just smooth this out and see and measure wall thickness along the way. Now, you don't like to use a scraper on a thin wall. By the way, the quality of that cut on that is excellent on the scraper. If you come up here, you might get too much vibration, so you have to use it in the shear scraping mode, which would be turning it on its side. Still got that's too thick right there. All right. I think I got to go down quite a bit in the middle. Okay. There. All right, I'm going to show you how the shear scraper works. You're presenting the tool to the wood at roughly at a negative rake and maybe a 45-degree angle. Those are nice shavings coming off. Okay, that's a good cut. I can still feel it's thick in there, but I'm going to stop. I think we've got the idea. I got another 1/8 of an inch to remove off the bottom. In the meantime, instead, I'm going to finish up by showing you how to handle something that's not round. So this one here, okay, this, okay, so this is the circle I want. You can see right here, it's only 3/16, and here it's almost 1/4 of an inch or even 5/16. So you can blend that by using 120 grit sandpaper on the drill press. So I'm going to show you that. By the way, the sandpaper I use the most is Klingspor. I buy it in 4-inch wide rolls. And I don't make the discs, I don't make them into discs, I just use them square. That's it. Less than 5 minutes, and it looks round. Okay, now the only other thing you might have to do on the drill press is you want to get this face as clean as you can. On mine here, I tried extra hard to get it it's a reasonably clean cut with no turnout. However, there's a few grooves in it. Those are easy to sand out, again, on the drill press by holding it all the way around. I'll do half of this, and you can see how 1 minute of sanding cures a lot of bad turning. Okay. Then you could also sand the top. Okay. So what I'll do at the end, after this is fully hollowed, I'll sand as much as I can on the lathe, which is not that much, just the inside of this bowl. Even that I do on the drill press quite a bit. Then I'll remove this, and I'll run it through the table saw to remove this. Okay, just zip it. And if I don't like something, like I'll have to inspect this. This looks like a little bit of when I was trying to flatten this off, I got that one catch. I have to decide if I'm going to just blend this in by sanding, or I'm going to remove it by turning. So I'm going to leave this on for now. I think that's it. This comes off with a chisel, and what I loosen up the hot glue with mineral spirits. Just pour it on there, let it sit for a minute or less, and then pry it open. You'll be surprised at how fast it comes off. And but you can see that the combination of the tape plus the glue was very robust. I mean, it handled 2 or 3 catches. This one was the worst, but I had a couple others. And so the only thing is I try to be reasonably careful hollowing it out and stopping quite a bit to measure the wall thickness, because I want to get it perfect. A lot of the bowls, you might not have to check a salad bowl as frequently as I would this. Yeah, you could square up all 3 sides with that if you needed to. Apparently different brands of glue stick work with different solvents. Yeah, I never had luck with alcohol, and I was talking to another guy. He says the only thing that works for him is acetone. So I have no idea why, but mineral spirits works great for me. Okay. And there's various grades of glue stick too. Some are like hobby grade, and some are like commercial or glue your roof on your grade.